The toilet in every bathroom is one of the most sophisticated pieces of engineering used daily, yet most people have no idea how it actually works. This device uses fluid dynamics, atmospheric pressure, and centuries of physics breakthroughs to make human waste disappear with the push of a button. Today's exploration dives deep into the surprisingly complex science behind flush toilets, from the ancient physics principles that make them work, to why that swirling water myth is completely wrong, to the cutting-edge engineering that's revolutionizing bathroom technology right now. This investigation draws from everything from 16th century toilet patents to modern fluid mechanics papers to bring the complete story. Plus, there are mind-blowing demonstrations that will change how anyone thinks about their bathroom forever. Three main areas will be covered. First, the hidden physics that makes every flush possible, which is way more complex than expected. Second, busting major toilet myths with actual science. And third, the incredible engineering innovations happening right now that most people have never heard of. Here's something mind-blowing. Toilets are basically carefully engineered waterfalls that defy gravity using nothing but clever physics. When that flush handle gets pressed, it triggers a chain reaction involving at least four different physics principles working in perfect harmony. Here's what actually happens. First, there's the tank mechanism. When the handle gets pushed, it lifts a flapper valve that's been holding back 1.6 gallons of water under gravitational potential energy. That water rushes into the bowl through carefully angled rim jets that create a swirling vortex. Not because of the Coriolis effect, which gets debunked later, but because of deliberate engineering. But here's where it gets really fascinating: the siphon effect. Toilet bowls have an S-shaped trap filled with water. When flush water enters the bowl rapidly enough, it fills that S-curve completely, creating a siphon. Once that siphon starts, it literally sucks everything out of the bowl through atmospheric pressure differential. The air pressure pushing down on the water in the bowl is higher than the pressure in the drain pipe, so physics does all the work. This siphon principle is the same physics that lets anyone empty a fish tank with a tube, but toilet engineers have perfected it over centuries. Without this precise balance of water volume, flow rate, and trap geometry, toilets would be nothing more than costly sculptures with plumbing problems. Now it's time to destroy some myths that even smart people believe, starting with the most famous one about water swirling in different directions in different hemispheres. Most people have heard that toilets flush clockwise in the northern hemisphere and counterclockwise in the southern hemisphere because of the Coriolis effect. This myth is so persistent that it's appeared in documentaries, TV shows, and even gets taught in some schools. Here's the truth. The Coriolis effect is real, but it's completely irrelevant for toilets. The Coriolis effect only matters for massive systems like hurricanes that operate over hundreds of miles in several days. For something the size of a toilet bowl, the effect is billions of times too weak to matter. What actually determines swirl direction? The design of the rim jets. Those little holes around the rim of toilets are angled specifically to create whatever swirl pattern the engineers wanted. Some toilets swirl clockwise, some counterclockwise, and some don't swirl at all, regardless of which hemisphere they're in. In fact, researchers have done controlled experiments with perfectly still water in large pools, and yes, the Coriolis effect can be observed, but only after eliminating every other source of motion and waiting 24 hours for the water to become completely still. Toilet flushes take 10 seconds, not 24 hours. This myth persists because it sounds scientific and involves real physics. But scale matters in science. Just because something works at one scale doesn't mean it works at another. Understanding this helps develop more critical thinking about scientific claims. But here's what's really exciting. Toilet technology is advancing faster right now than it has in the past 100 years, and most people have no idea. We're living through a toilet revolution driven by water conservation, smart technology, and some seriously advanced fluid dynamics. Engineers are completely rethinking how toilets work. Take dual flush systems, which aren't just about having two buttons. The engineering behind them involves precisely calculated water volumes and flow patterns. The small flush uses about 0.8 gallons and creates a different hydraulic pattern optimized for liquid waste. The full flush uses 1.6 gallons with a completely different vortex pattern designed for solid waste removal. Then there are pressure-assisted toilets that use compressed air to literally blast waste away with incredible force. These systems store pressurized air in a tank inside the regular water tank, and when flushed, that compressed air forces the water out at much higher velocity than gravity alone could achieve. But the real cutting-edge developments are happening with smart toilets that use sensors, heated seats, and even UV sterilization. Some models analyze waste for health indicators. These are toilets that could detect early signs of diabetes or digestive issues just from daily routine. This matters because toilets represent a massive part of global water usage, about 30% of household water consumption. Better toilet engineering isn't just cool technology, it's essential for water conservation as population grows and climate change affects water supplies. And here's something that makes toilets even more impressive. The manufacturing process is absolutely incredible. Every toilet started as a liquid clay mixture called slip that gets poured into plaster molds. But here's the genius part. The plaster absorbs moisture from the slip, creating a solid layer while keeping the inside hollow. This is why toilets are strong but not solid clay all the way through. After molding, toilets get fired in a kiln at over 2,000 degrees Fahrenheit, then glazed and fired again. The glaze isn't just for looks, it creates a non-porous surface that's essential for hygiene and easy cleaning. The whole process takes about 40 hours and requires incredible precision to get all those curves and internal waterways exactly right. This manufacturing complexity is why good toilets last decades. These aren't just bathroom fixtures, they're precisely engineered ceramic sculptures that have to handle extreme forces, temperature changes, and constant use while maintaining perfect hydraulic performance. So, there it is. Toilets aren't just simple bathroom fixtures. They're sophisticated engineering marvels that combine fluid dynamics, atmospheric pressure, precision manufacturing, and centuries of innovation. From the siphon physics that makes flushing possible, to busting myths about hemisphere effects, to the incredible technology being developed right now. The next time anyone flushes, they're witnessing physics in action, using technology that represents hundreds of years of human ingenuity, all working together to solve one of civilization's most important challenges. And if the physics behind everyday objects seems as fascinating as it should, there's another video about the surprising science behind something else used every day, but probably not understood, that you can find on the screen right here. The engineering principles are completely different, but equally mind-blowing. Thanks for watching. If you enjoyed, please like, share, and subscribe for more everyday wonders simply explained.